Now in this class we are going to discuss about the next concept, that is data hazard. Okay, so already I have started the concept of pipelining. Okay, so in that we discussed what is a pipelining and why our computer makes use of that pipelining concept. Okay, so what is the reason behind of that? So the main reason is the pipelining is used to enhance the performance of our computer, right? So now even though pipelining has a lot of advantages, okay, so there are some problems that can come when our computer makes use of this pipelining concept. Okay, so what are the problems that our pipelining introduced? Okay, so in that each and everything we have to discuss now. Okay, so what are the problems that occurred in while using in pipelining concept? So now we'll see all those things. Okay, so one of the big problem that can be happened in a pipelining, that is a data hazard. Okay, so first we will discuss about the data hazard concept. So what is a data hazard and what type of problem can come in a pipelining with a data hazard? Okay, so with the help of this diagram I am going to explain that. Okay, so how this data hazard can occur in our pipelining concept. Okay, so what is a data hazard? So first of all, what type of problem can occur in a pipelining? So let us see the definition first of all. Okay, so here what is meant by data hazard means, so a data hazard is a situation in which the pipeline is stalled because the data to be operated on are delayed for some reasons. Okay, so delayed for some reasons. So this is the definition of data hazard. Okay, so what is meant by data hazard, ma? So a data hazard is a situation in which the pipeline is stalled. Okay, so this is very important point here which means the normal function of a pipeline is the output of instruction 1. Okay, so output of instruction 1 will pass to the instruction 2. Like that, output of instruction 2 will pass to the instruction 3. Right? So like that up to so on. So that means in that each and every instruction of the output will pass to the next instruction. Right? So that is a pipelining concept. That means if the pipeline is not working properly, that means if the output will not pass to the next stage. Okay, so if the pipeline is not working properly, if it is getting stopped. Okay, so if it is not working properly, if it is automatically getting stopped due to some unwanted problems, it automatically stop that process. Okay, so then this situation is nothing but data hazard. Okay, so here what is meant by data hazard actually? So if each and every instruction output will pass to the next stage, okay, so but if the pipeline is not working properly, that means if the output will not pass to the next stage of instruction, so that means it automatically stop that procedure. So due to some unwanted problems, it's not working properly. Okay, so then this situation is nothing but data hazard situation. So by using with this introduction of hazards, okay, our pipelining will get stopped or it will stalled. Okay, so what causes our pipeline get stalled? Now we'll see here. Okay, so what causes our pipeline will get stalled? Okay, so we will see now that what causes and based our pipelining will get stalled means with one example we will see that. Okay, so this is our example. Here I mentioned that is nothing but clock cycles, and you have the instructions also there in that. Okay, and instruction procedure will be there here. Already you know this instruction procedure, right? So now we'll see here. So let us consider these are the clock cycles. Okay, so that clock cycles from 1, 2 up to so on up to 9 clock cycles we are having. Okay, So, and these are the instructions. Okay, so that instructions are started from 1, 2 up to so on 5 instructions we have. Okay, so now in instruction 1, okay, so now coming to the instruction 1, so these are the steps we have taken. You know, right, how to execute the instruction, what are the procedures will have in that. So that means on what basis the instruction will be executed means it will be having the generally 3 steps. That 3 steps are fetching the instruction, decoding the instruction, executing the instruction, right. So here also the same thing will be repeated. So now in instruction 1, these are the steps we have taken, those are F1, D1, E1, W1. So that means I will explain each and every term here. This is F1 is nothing but fetching the first instruction, D is nothing but decode, that means decoding the first instruction, and E is nothing but execution of first instruction, and W is nothing but writing the instruction. Okay, so this is about instruction 1. So now coming to the instruction 2, instruction 3, instruction 4, instruction 5. So these are also having same cycles, that means same steps we are having, but this is not a normal working of a pipelining. That means coming to the second instruction, third instruction, fourth and fifth instructions, you can observe clearly here. So this is not a normal working of a pipelining concept, because in instruction 1, so for this instruction of for this execution of instruction 1, these are the 4 steps. Okay, so these are the 4 steps we are having, that is F1, D1, E1, W1, right. So once stands for all these steps related to the instruction 1. So when the execution of these complete instruction will takes place at the end of the 4th clock pulse, right. So just observe here, fetching the instruction 1, that will take the 1 clock cycle, and D1 will take the another clock cycle, and E1 will take the 1 clock cycle, and writing operation also take the 1 clock cycle. That means when the execution of these complete instruction will take place at the end of the 4th clock cycle. So first it will started at the 1st clock cycle and it will end up with the 4th clock cycle. So here the complete execution of this instruction 1 will takes the only 4 clock pulses, right. So now coming to the, when the decoding of the first instruction, okay, so just observe here, when the decoding of the first instruction will proceed, okay, so after fetching the instruction 1, then it will be next step, then that after fetching the instruction it will be goes to the next step as decoding step, right. So that means when the decoding of the first instruction will proceed, during this step only the fetching of the second instruction will be takes place. Just observe here. So while taking the while during the decoding procedure, automatically the second instruction will be fetched. In the second clock cycle, during the decoding of execution, during the decoding of the instruction 1, automatically the second instruction will be takes place in second clock cycle, right. So that means here F2 will be started. But you can see here in the execution of the instruction 2 there is a delay. Just observe here, the execution of the instruction 2 will be having some delay. Just observe here, instruction 1 will be executed in only 1 clock cycle, no, but coming to the instruction 2 will takes for execution purpose, how much time it will take means, so the 4th clock cycle will be taken, and 5th will be taken, and 6th one also taken, right. So that means you can see here in the execution of instruction 2 there is a delay which has happened here. Okay, so there is a delay which has happened here. So which means actually this E2 must be completed at the end of the 4th clock only. Just observe here, each one will take only 1 clock cycle now. So D2 will take the 3rd clock cycle, but coming to E2 also will end up with the 4th clock cycle, right. But here E2 will not complete in 4th clock cycle. Okay, so this E2 must be completed at the end of the 4th clock cycle itself actually, but what happened, due to some problem the execution of the second instruction got delayed. Okay, so from 4 to 7 clock cycles. Okay, so in this clock cycle region the execution of the second instruction will got delayed. So how long it delayed? So you can see here it got delayed from 4 to 7 clock cycle. So which means the end of the 6th clock cycle, okay, the end of the 6th clock cycle, E2 got executed. Okay, so now after we are writing the second instruction. Okay, so after that we can take the writing of the instruction will takes place. Okay, so now what happened here? If the execution of the second instruction got delayed, okay, automatically it will be effect on the third instruction. Okay, so once any one instruction will got delayed, automatically that effect will be present on the next instruction. Okay, you can see here because of the delay of execution of the second instruction, okay, it will take this time now. So because of this delay of the execution of second instruction, the execution of third instruction, okay, the execution of the third instruction will also got delayed in this region. Just observe the thing. Okay, so why the execution of third instruction got delayed here? Because still our step D3 has not completed here. Okay, so when D3 will complete, D3 will complete, that is nothing but whenever E2 will complete, automatically the D3 will be completed. That means, so this execution will be depends upon the third of the decoding procedure. So it's not completed means automatically it is also not completed. Okay, so when D3 will complete, so when V2 will complete. So similarly, when D4, okay, so when D4 step will complete means whenever, when our D3 step will complete or when D3 step is going to be complete, so which means all of you, you can get one idea from this, and that is nothing but the second instruction is depends upon the first instruction. Okay, second instruction is depends on that first instruction. Like that, third instruction will be depends upon the execution of the second instruction. Like this way, fourth instruction will be depends on the execution of the third instruction. Like this way, fifth instruction will be depends upon the execution of the fourth instruction. So that means in any instruction, okay, that means in any instruction, if one of the step is got delayed, if any one of the step is got delayed, okay, then automatically it will be effect on the next. Okay, then it will be automatically effect on the execution of the remaining instructions. So this is known as data hazard. So this is the problem we raised with the help of this data hazard in pipelining concept. Okay, so the definition of data hazard is, it is a situation, okay, in which the pipeline is stalled. Here you can see that pipeline is stalled, no? Okay, here you can see that pipeline is stalled. Why the pipeline is stalled? Because the data to be operated on are delayed for some reasons. Okay, so here we are seeing the delay 4, 5, 6 clock pulses. Okay, so actually the E2 must be executed at the end of the 4th clock cycle only. But when the E2 will complete this execution at the end of the 6th clock cycle, okay, so there is a delay of 2 clock cycles we are having. Okay, so because of this delay, pipelining will get stalled. So this is the complete explanation about data hazard. So which problem we can occur with the help of pipelining concept means, so this is the problem we can raise, we are observed in data hazard concept of pipelining. Okay, so this is the complete explanation about the data hazard. Okay, so you have one more definition in that, that you can check it in the material. Okay, so that is nothing but either the source or destination operands of an instruction pipeline are not available at the time expected in the pipeline. Okay, so you can go and check the notes or you can go and check the material. So you can observe the one more definition of data hazard. So that is also same thing appeared. That means it is also raised that same situation. Okay, so this is the complete explanation about the data hazard concept.